Good evening, students. We are once again in the physics class, and I, Mr. Avijit Kundu, is once again with you with another topic of physics, electromagnetic induction and alternating currents. So we are already we are completing our physics course for NEET, and you know what kind of questions we'll be having, right? You are already aware of the numerical styles of the questions and also the fastness of solving them, right? So today the topics that we will discuss are these are the topics on which mostly all of them or most of them will be solving problems. So what are they? Magnetic flux. Okay, before going into the topics, first let me tell you, electromagnetic induction and alternating currents. So they come just after the magnetic effects of currents. Now you have to understand or you have to remember most of the laws and the principles of magnetic effect of current to understand these topics, right? When we come into electromagnetic induction, it means here because of magnetism or the change of magnetic flux, we are generating current. And what kind of current it will be? It will be mostly the AC, that is the alternating current. So we are combining both these topics together, and these are the subheadings we'll be dealing with today. What are they? Like magnetic flux, right? Do you remember what is the basic formula? Like how to calculate the magnetic flux? Magnetic flux is nothing but the number of lines passing through an area. And from magnetic flux, the rate of change of magnetic flux, if it changes, then it develops a EMF. So we'll be using this formula, the basic formula d phi dt, where phi is the magnetic flux, right? Which comes under nothing but the Faraday's laws of electromagnetic induction. So we are inducing EMF and also a current by this formula, right? This minus leads to the concept of Lenz's law. Like, now what does a Lenz's law says? Lenz's law is nothing but which says that the effect, right? The EMF will be produced in such a way that it will oppose the cause, right? We will see how this thing we can actually use in the problems, right? Like if a magnet which is passed through a coil, right, we will see it is inducing a voltage within the coil, and also it is inducing some current. The current will flow in such a way that it will generate a magnetic field which will oppose the magnet which is creating this EMF. And this Lenz's law, and hence for this Lenz's law we provide a minus sign into the formula, then which will lead to the motional EMF, right? Inductance, self and mutual, right? You should remember the formula, like E equals to minus L di dt for self inductance. For mutual inductance it will be E equals to minus M di dt. M is a mutual inductance. We'll move on to LC oscillation, and this will be also covered in the topics of AC. Motors, generators and transformers, you need to know the basic structures and the formula and the functionality of each part. Alternating current, RLC circuit, right? So let us start with the problems and see. And for NEET, very simple problems comes by direct application of formula, graphs, right? Let us see. The first problem, an EMF of 5 volt is produced by a self-inductance when the current changes at a steady rate from 3 ampere to 2 ampere in 1 millisecond. The value of self-inductance is, let me change the color of the pen. See, an EMF 5 volt is produced by self-inductance. Which formula to use? Yes, E equals to minus L di dt, where E is given 5 volt, right? current changes at a steady rate from 3 ampere to 2 ampere in 1 millisecond. So here, so change, we have to find out di dt. It means we have to find out the change of current divided by the change of time, right? So here del I is equal to how much? From 3 ampere to 2 ampere, right? That is 2 minus 3 is the change. It is not 3 minus 2. Divided by, what is the time? 1 millisecond. Del T equals to 1 millisecond. That is 10 to the power minus 3 second. So di dt is actually nothing but del I del T, that is minus 1 amps divided by 10 to the power minus 3, that is minus 10 to the power 3 this. Okay, now we have to find out the L. Now see, L is then nothing but E divided by di dt. If we put E is nothing but 5 divided by, it is minus, and it is minus 10 to the power 3, minus minus cancels out. It becomes how much? It is 5 into 10 to the power minus 3, and the unit of inductance is nothing but Henry, H. So 10 to the power minus 3 means we can write it is 5 millihenry. Got the point? Understood? Okay. Moving on to the second example. A 50 millihenry. We are dealing with 5 millihenry. Now the coil is having 50 millihenry coil. Carries a current of 2 ampere. The energy stored in joules is. These are very simple formula oriented sums. What formula we have to use? Yes, you know the energy stored in an inductance is nothing but half L I square, right? I is nothing but 2 ampere, L is given 50 millihenry. So what will be the value? It is 50 into 10 to the power minus 3 into I is nothing but 2 ampere. So 2 square it is given, right? So 2 into 50, 100 into 10 to the power minus 3, that is it is nothing but 0.1 joules. Clear? So very simple formula putting problems. Moving on to the next one. This is an interesting question. See, a rectangular coil ABCD is rotated anti-clockwise like this with a uniform angular velocity about the axis shown in diagram. This is the axis and it is rotated in the anti-clockwise direction. The axis of rotation means this, as well as the magnetic field B, right, are horizontal. So you can think this is the magnetic field and this is the axis, right? The induced EMF in the coil would be maximum. Induced EMF in the coil will be maximum. We'll not apply the formula here right now. First try to understand. See, you know from the theory, the magnetic flux is nothing but the amount of lines crossing through an area. So a magnetic flux, suppose this is nothing but the magnetic fields and this is the area. So when the plane of the area is perpendicular to the magnetic lines of force, then the flux will be maximum. Right, the flux will be maximum at the time. But what we have to find out? The induced EMF in the coil would be maximum. The question is not when the flux is maximum. So we don't want flux. No. The induced EMF, this we want. Right. Now, for induced EMF, what do I know? Minus d phi dt. That is, we have to basically find out when the rate of change of flux is maximum. The rate of change of flux, not the flux. Now see, when the coil is like this, when the plane of the coil is perpendicular to the magnetic lines of force, then the flux is maximum. And when the flux is zero, the flux is zero when the plane of the coil is parallel to the magnetic field. Then see, no lines of force are crossing the, lines of force is crossing the area, right? So at that, in this case, you can say the, the flux is zero. So you can say like when, and so the flux varies from zero to maximum. So when from any point it reaches zero, at that time the rate of change of flux will be maximum, because we are from a finite value we are reaching zero. So the induced EMF will also be maximum when the plane of the area is parallel to the magnetic lines of force. The answer will be the plane of the coil is horizontal. Now try to find out from the formula. You know the induced EMF, if you study the formula well, you will see E0 is the maximum value of the induced EMF, sine omega t. Right, sine omega t is the angle made by, omega t is nothing but the angle made by the magnetic lines of force and the area vector. Now you know the area vector is perpendicular to the plane of the, to the plane of the area, right? So when the plane is perpendicular to the magnetic lines of, the lines of force, then the area vector is parallel to the magnetic lines of force. And when the plane is horizontal, then the area vector is perpendicular to the magnetic lines of force. Now, when it will be maximum? When sine omega t is 1. Sine omega t is 1 when omega t equals to 90 degree, means the area vector is perpendicular with the magnetic lines of force, which means nothing but the area is parallel to the magnetic lines of force. Understood? Clear? So by both the way, one is theoretically understanding why the flux is maximum, because when the plane of the coil is horizontal, at the same time trying to use the formula. I hope it is clear. Okay. Okay. Let me just check if any. Okay. Fine. An electric potential difference will be induced between the ends of the conductor shown in the diagram. See, north, south, right? There is a conductor. See, there are 4 regions marked: L, M, Q and P, right? When the conductor moves in the direction, the question is, electric potential difference will be induced in the coil when the conductor will be moved along L, along Q, along M or along P. Same thing, you know that induced EMF will be induced when there is a cutting of the flux. The flux should change, right? You can very well see if the conductor is moved Q-wise or L-wise or P-wise, flux is not, flux length is not cut, right? The flux length is only changing when it is moving like this way, because magnetic fields are from this to this. If we move the conductor up, right, in the direction of M, then only the conductor is cutting the magnetic lines of force. Clear? And hence, only electric field, electric potential difference will be induced only when the conductor is moved in the M direction. That is, the answer is D. Clear? Moving on to the next question. Okay. In electromagnetic induction, the induced EMF in a coil is independent of. It is dependent on flux, is dependent on time, but it is independent of the resistance, because E is nothing but minus d phi dt. If you have to calculate the current, then the parameter resistance comes. For EMF, for induced EMF is independent of the resistance of the circuit. Clear? Okay. Now this question is a small numerical application of the previous concept. Very interesting question. The magnetic flux through a circuit of resistance R changes by an amount del phi in del T. Then the total quantity of electric charge Q which passing during this time through any point is given by. So EMF equals to minus del phi del T, right? EMF is this. How to find out the charge Q? First we have to find out the current. Current is nothing but EMF by resistance, because the circuit resistance is R, is minus del phi R del T. Clear? Okay, if this is the current, then the total quantity of electric charge is what? Charge is nothing but charge is nothing but current into the time, right? Current passed through a certain interval of time. For this current, we are only considering the numerical value, because here charge is a scalar quantity. We are not bothered about the sign. It is nothing but del phi R del T into del T. So this cancels out. It becomes del phi by R. So answer will be D. Clear? Observe one thing. For most of the problems of these chapters, in the later chapters, you will see not much application of the formula, and you're not using multiple formula. You're using only 2-3 formulas, 1-2 formula, but direct application of them. Clear? So that you can score high and you can also finish the questions. You have to be very fast. Clear this one? Yes. Okay. Now see this question. A metallic ring is attached with the wall of a room. When the north pole of a magnet is brought near to it, the induced current in the ring will be... Okay. Now this is the application of Lenz's law. I was explaining. So definitely if north pole arrives towards the ring, then definitely the induced EMF will be produced in such a way that it will, the current will flow in such a way that this will also be a north pole, right? And you know, if you can draw N like this, to produce a north pole within a circular coil, the current should flow in the anti-clockwise direction. And to produce a south pole, the current should flow in the clockwise direction. Now, by Lenz's law, as north pole is approaching, a north pole should be generated. It will oppose the motion. So, make a north pole. This will be anti-clockwise. Means like this. Okay, so the answer is in anti-clockwise direction. But see, one thing, first clockwise, then anti-clockwise. First anti-clockwise, then clockwise. These things are also given. How we can modify the question to have answers like this? If we only ask in which direction the current will flow if the magnet is taken near to the ring, then there is only one answer, right? Now if I say the magnet is taken across the ring, it is passing through the ring and going in the, it's going in the downward direction. Then what will happen? Now see, if the magnet goes down, then there is a south pole, right? the South Pole is going away. The South Pole is going away means, very interesting, the South Pole is going away means to oppose the motion, the other part, right, the other part will generate a North Pole so that it can attract it. To generate a North Pole, again the current will flow in the anti-clockwise direction. So metallic ring is attached with the wall of a room. When the North Pole of the magnet is brought near to it, induced current in the ring will be first North Pole. So this area or this region will also be a North Pole. To be a North Pole, right, it will the current will go in the anti-clockwise direction. It is opposing. Now if I can show like this, like suppose you consider this is the North Pole, this is the South Pole. The North Pole, so this will be a North Pole now, right? If it goes away, as it is coming near, so it will be a North Pole to oppose the motion. If it goes down, right, then South Pole is going away. The opposing the motion will be to attract it. To attract it, this should be again a North Pole. For North Pole, this will be in the anti-clockwise direction. So for both the thing, if we consider both the things, the answer will be in anti-clockwise direction. So these things actually, we get confused with this kind of answers. Immediately we have, we tend to think, okay, as it is passing through, maybe it will be clockwise and then anti-clockwise. Not like that. We have to actually analyze what is happening over there. Clear? Moving on to the next question. Okay. Now we have come to a next question of alternating current. Let us see, not alternating current, of electromagnetic induction. An alternating current of frequency 200 radian per second and peak value 1 ampere. Peak value 1 ampere and 200 radian per second. So what is this? Is nothing but frequency. But what frequency? Not the normal frequency, but the angular frequency. So 200 radian per second means it is nothing but omega. That is nothing but 2 pi f. And peak value 1 ampere is shown in the figure, is applied to the primary of a transformer. If the coefficient of mutual induction between the primary and secondary is 1.5, as it is a transformer, it is having two coils. When there are two coils, the coupling of magnetic lines of force will be a mutual coupling. So we need the coefficient of mutual induction, which is 1.5 Henry. The voltage induced in the secondary will be. Here also the main formula remains the same. E equals to minus m di dt. The m we know. We have to find out the di dt. We have to, now I and t, they are not given specifically. But see how the current is changing. The current is changing from 0 to maximum 1, then 1 to 0, again to minus 1, like this. Now the change is occurring between, between this is one wavelength, right? Or one period, you can say. This is one period, right? The way the wave is changing, this is one period. So this is time t, right? The total time period t. The change is occurring between t by 4. In every t by 4 it is changing. So we can take the duration of time to be t by 4, where t is the time period. T is the time period. Okay. So we can write minus m. M is nothing but 1.5. Di is change of current. Current is from 0 to 1. So we can write nothing but 1 minus 0. For dt is nothing but 1/4 of time period. So it is t by 4. That is, we can write minus 1.5 into 4 divided by t. Now t we don't know. T is the time period, but we know the frequency, or the angular frequency, right? Now we know f equals to what? Omega by 2 pi, and t equals to 1 by f. That is 1 by f 2 pi by omega. Right? We know the omega. Now in place of t you can put that value 2 pi by omega. So it becomes what? Minus 1.5 by into 4, it is 6. In place of t, if you put omega, 2 pi, t equal to 2 pi by omega, so omega goes up. This is t, that is 3 into omega. Omega value is 200. 200 divided by pi, that is 600 divided by 3.14. If you calculate, say 600 divided by 3.14, you will not get actual time to calculate. How will you find out? Definitely 300 will not be there. Not even 220, right? Because 600 divided by 3 is 200. So it should be less than 200. So it is only 191 volt. So this will be the answer. 600 divided by 3 is 200. So it should be less than 200. So that is only 191. So you don't have to calculate that. Just apply the formula and apply your basic logic. That is approximately equals to 191 volt. So this is our answer. Clear? Okay, any more doubts are coming? Okay, fine. Moving on to the next question. Okay, similar questions. A rectangular loop is being pulled at a constant speed through a region of certain distance, certain thickness d, in which a uniform magnetic field B is set up. See, B is set up, cross is given. So means what? In which direction the magnetic field is going through? Inside. Cross means inside, right? The graph between position x of the right hand edge of the loop, right hand edge, and the induced EMF will be. So what they are asking, there is a loop. The loop is moving through the magnetic field, right? As it is moving through, right? It is going on cutting. The flux linked with the coil is slowly increasing and increasing at a constant rate because the velocity is moving at a constant speed v. So as it is moving at a constant rate, it means its rate of d phi dt, rate of change of flux linked, right, is constant because it is moving at a constant velocity. Then definitely EMF generated will be constant, right? Now EMF generated will be constant when the whole loop will enter this magnetic field region and the whole loop will go. Then there will be no change. At that time it will come to zero. The EMF will be zero. And as it is going out, then what will happen? The EMF will be, the flux link will be decreasing. And again the EMF will be produced. And EMF will be produced and constant. Now see, EMF will be produced and this EMF as d phi dt is constant, right? So EMF generated will be constant going to zero. Then again when it is going out, when it will go out, then what will happen? Again the flux link will be decreasing at a constant rate. So EMF generated will be again be constant. Let us try to analyze this in the graph. In the graph, see, these two graphs will definitely fit our bill because here the EMF is generated not constant, it is increasing. So this cannot be, even this cannot be. Though here a change from zero increasing, then it is coming to zero, these are there but they are not constant. So our probable answers will be either A or B. Now whether A or B, that we need to find out. Now EMF is just not d phi dt. EMF is minus d phi dt. Now you have to understand the value of minus or the use of minus. Minus means that d phi dt is a change of flux at a constant rate but it is increasing. As it is increasing, the EMF will be negative. The increasing means positive, so d phi dt is positive, so EMF will be negative. Negative, and when it is going out, the d phi dt is decreasing. D phi dt decreasing means what? d phi dt is negative. So negative, negative, EMF will be positive. So first it will be negative, then it will be 0, and then positive. This will be negative to 0. This will be positive. So definitely this will be the answer. Here it is constant, negative, then coming to 0, and then constant, positive. Because it is minus d phi dt. This cannot be the case. Clear? So for this kind of question, first you see what need to be found, and then how we are applying the graphs. Graph question is very necessary, right? And why these two will not be there? First we get rid of this, right? You must have seen that Kaun Badega Crorepati, right? In 50-50 we just get rid of the most unwanted answers. Then with the probable answers, we look into the actual answer. So these two will be the probable answers, but in that, this is the answer, because first d phi dt, when it is positive, then EMF is negative. Then when moving out, d phi dt is negative, EMF is positive. This will be the answer. Okay. Moving on to the next question. Resonant AC circuit contains a capacitor 10 to the power minus 6 farad and an inductor of 10 to the minus 4 Henry. The frequency of electrical oscillations will be resonant AC circuit. So what formula will use? For resonance, you know, for LC oscillation, right? Omega is nothing but 1 by root over LC. And omega is equal to 2 pi f. So f is nothing but 1 by 2 pi root over LC. If we just put the formula, you will get L is what? 10 to the power minus 4, and this is 10 to the power minus 6. This becomes 10 to the power minus 10. 10 to the power minus 10 within root, it becomes 10 to the power minus 5, which goes up and becomes 10 to the power 5 by 2 pi hertz. Simple formula putting. Mostly what happens here, people mistakes in root over, like omega equal to 1 by root over LC. Many times we tend to click this answer, but no, it is frequency, not the angular frequency. For frequency, it will be this by 2 pi, because it's hertz. And if it is omega, if it is angular frequency, then the unit will be, yes, radian per second. Next question. Okay, this is a very interesting question. L, C and R denote inductance, capacitance and resistance respectively. Pick out the combination which does not have the dimensions of frequency. Right? These, if you remember, the LCR combination of circuit, it can be LC combination, CR combination or RL combinations. Right? We can find out. For each combination, we have a resonant frequency and also, the resonant frequency, which the angular frequency. So we can find out. For LC, it is nothing but 1 by root over LC, right? For RC, if you remember, it is 1 by RC, and for RL, it is R by L. So these three denotes the resonant frequencies, right? So only this is not having the dimensions of frequency. For this, to know it, to understand it better, you can also use the dimensions of each and every parameters or the variables we are using, right? For dimensions, right, you know, go into the original dimensions, right? For resistance, we have to use voltage by current. Voltage is nothing but watt per unit charge. Voltage is nothing but, watt per unit charge, so we have to go to work. For current, so like that we have to see. For capacitance is nothing but V equal to Q, Q equals to C into V. So C is nothing but Q by V, right? By all these things, if you do, you will finally get for this, and for this, For all these, the dimensions will come t to the power minus 1. T to the power minus 1 means what? Time 1 by t. 1 by t is nothing but frequency. Because frequency, the dimension is t to the power minus 1. By that way also you can verify all these things. Right? For R, how will you find out? For C, it is very simple. Q by V. Q is nothing but I into T. I is ampere. A into T by V. You can do it. Right? For R similarly, for R, V by I. If you use a basic formula, you can find out. How to find out dimensions of L? We are doing that. Minus L di dt. Here also. E is voltage. Di dt. If you divide, you will get the dimensions of L. If you put all the dimensions, you will finally get all of these. The dimension will be t to the power minus 1, which is nothing but dimension of frequency. Understand? Clear? Okay. Almost we are in time. Question. In an AC circuit, V and I, now RLC we have done, now AC circuit, V and I are given by V equal to 100 sine 100 t volts, I equal to 100 sine 100 t plus pi by 3 milliamps. The power dissipated in circuit is, what is the power dissipated? Now, what is the formula of power dissipation? It is Vrms into Irms into the power, cos of the power factor, cos phi. Right? Now, Vrms is nothing but V0, the maximum amplitude, the maximum value of the voltage by root 2. Irms is nothing but I0 into root 2, and cos where phi is the power factor. Now see, V equal to this, so this is V0, I equal to, in the formula, this equals to I0, and power factor phi is this. So if you put the value, right, it is 100 by root 2. Okay, current is milliamps. So when you put the value of current, it is not 100 but 100 milliamps. So 100 into 10 to the power minus 3 divided by root 2, definitely, into cos of phi, into cos of phi is pi by 3. So it happens what? 100 10 to the power minus 3, it becomes 10, right? It becomes 10 divided by 2. Cos of pi by 3 is cos of 60 is half. Half, it is nothing but 4, 2.5. As we are calculating power, our unit will be watt. That is 2.5 watt is the answer. Clear? Okay. So this much for today, right? Go on practicing similar kind of problems. Don't go into much details, right? How to apply the formula directly. Graph problems are very necessary. One thing I could not finish because of time, or I could not discuss, that is on generators and motors, right? Functions of each parts and how graphical problems and problems will be there, right? And also go on practicing more problems on AC, right? On AC and RLC circuit, all these things, right? Best of luck for all of you for the NEET exam. Prepare well, and if any doubts, log on to our website. Okay, and thank you. Good going.